We'll start today by looking at the mixed review problem. So in this mixed review, they're asking what is the slope of the line passing through this pair of points. And if you remember from the previous lesson, slope represents the change in y over the change in x. So we could use the formula for slope. So this would be x1 and y1, and this would be x2 and y2. Or we could just look at how it's changing. How is the y changing from 1 to 8? You can see it's changing by 7. And then how is the x changing from -6 to 4? So we can see it's going up by 10. So my slope should be 7/10. Now, if we were going to use the formula, another way to do it would be 8 minus 1. So y2 minus y1 over x2 minus x1. And we can see that we would get the same solution. I just kind of took a quicker path there, just remembering that slope is always going to be change in y over change in x. Now, we're going to continue discussing slope, but we're also going to look now at slope-intercept form. And I think that some of you are familiar with this already, but I think it's also a good reminder, and we may be doing some problems with slope-intercept form that maybe you haven't done in the past. So we're going to be working with linear equations, and those equations model linear functions. So in a linear equation, the variables cannot be raised to a power other than 1. So, for example, y equals 2x is a linear equation. That would also be direct variation. But y equals x squared and y equals 2 to the x power are not linear equations. The graph of a linear equation contains all the ordered pairs that are solutions. So the whole reason that we graph an equation is to show which points the x and the y would work when you plug them back into the equation. So graphs of linear functions may cross the x-axis at any point, the y-axis at any point. So that refers to the y-intercept of the graph. That is the y-coordinate of a point where the graph crosses the y-axis. So in the picture here, our y-intercept for the red line would be at 0, because that's where it's crossing the y-axis. And our y-intercept for the blue line would be 3, or -3, because that is where the blue line is crossing the y-axis. So we can use slope and y-intercept of a line to write and graph an equation of that line. So today we're going to kind of focus on the equation portion, and then tomorrow we'll focus on the graphing portion. So we're going to kind of split this up into a couple of days because it is important. You'll be using this a lot. So the slope-intercept form of a linear equation is this formula, which you may already be very familiar with. Y equals mx plus b, where m represents our slope and b represents our y-intercept. So that's just that standard equation that we use when we talk about linear functions. So in this example here, what are the slope and y-intercept of the graph? Y equals -2x minus 3. So the equation here is solved for y, but it's easier to determine the y-intercept if the y is on the right side of the written equation. In any case, we can just identify here the slope is -2 and the y-intercept is -3. Remember, it has to follow the formula. So it has to follow, here's my m, x, plus my b. Well, in this case, it's minus, but you get the idea. So the -3 is in the place value of where the b is. The -2 is where the m is. So we just want to be able to identify those pieces in an equation. Here is another example. So what is an equation for the line with slope of 2/3 and a y-intercept of 9? So with this problem, we're basically just plugging them into the formula. So we have y equals mx plus b here. And we're going to replace the m with the 2/3 and replace the b with the 9. So we have our equation. Just using some substitution there. So here we have our first got it question. What is the slope and y-intercept in this equation? So we're just identifying those pieces, which I'm hoping you're familiar with. But if you're not, this is a good chance for you to learn that. So here we have -1/2, which is where our slope should be. So I'm just going to label that m. And 2/3 is where our y-intercept should be. So that will be our y-intercept. So just labeling and knowing what the pieces are in that equation. Our next part is writing an equation in slope-intercept form. So taking your slope and your y-intercept and plugging it in. So for this equation, we would have y equals, our slope is 3/2, so we would plug that in for m. And then our y-intercept is -1, so I would just go ahead and say -1. So following that equation, y equals mx plus b. Just plugging the numbers in there. The next problem is writing an equation from a graph. So what we have to do is find our two pieces of information. So I'm looking for what is my slope and what is my y-intercept. And I'm just going to use b for y-intercept as that is part of our equation. So when we're finding slope from a graph, remember we want to pick points that are at an intersection of the graph. We don't want to pick a point that is in the middle of a box. So I could pick this point here. I could use this point. I could use this point. So as long as the point is at that intersection of the grid paper, then you're fine. And we want to find our slope by counting our rise over our run. So in this case, we're going up 1 and we're going left 1. So left always means a negative value. So up 1, left 1. So our slope is going to be -1. Remember, it's the rise over the run when we're graphing. So technically it is 1 over -1, but that can be simplified. So we always want to make sure that we simplify that slope. Then next thing we want to do is look where the graph is crossing the y-axis. In this case, looks like it's crossing it at 2. So my y-intercept is 2. So now I have enough information to write the equation of the graph. So my equation will be y equals -x plus 2. And you can say -1x, but most of the time in algebra, we don't write the 1 if there's just the 1 in front of the variable. So this is how you would see it in on tests and things like that. So our last problem for the day today is following kind of this pattern here. So it's asking what is an equation in slope-intercept form for a line that passes through these sets of points. So they're not giving us the slope and they're not giving us the y-intercept. So what we have to do is calculate those so that we can write the equation for the line that passes through these points. I'll make this a little bigger here. Okay, so first of all, it kind of breaks it down for you into steps. So we could say, okay, this is step 1. So we're going to substitute the 2 given points up here into the slope formula to find the slope of our line. So that is step 1. So remember, we plug them in for y2 minus y1 over x2 minus x1. That's where they got these values. And remember also, when you have a minus and a negative sign, remember they become plus a positive. So we would simplify this to get 2 for our slope. Now, the second step then is to now substitute our slope that we figured out and one of the coordinates into the slope-intercept form so that we can solve for b, because we don't know at this point what our y-intercept is. So we start with the original formula, y equals mx plus b. I'm going to take 2 and plug it in for m, and then I'm going to take one of the points. So they used looks like they used the first point here. So we're going to take 1 and plug it in for x, and we're going to take -3 and plug it in for y. So now we have an equation that we can solve for b. So 2 and 1, that would give us 2, so we're going to subtract the 2, and that would give us -5 is b. So now we have our 2 elements. We have our slope is 2, and we solve for our y-intercept, that is -5. So then our third step is to substitute those 2 answers into the slope-intercept form. So here now we can write our equation. So this equation has a slope of 2 and a y-intercept of -5, and it goes through the 2 points that were given in the original question. I'm going to stop here because, well, let's see if I can go. I've got a couple minutes left, so let's see. Let's go ahead. This is our last problem for the day, and we're just going to follow those steps above. So I think that we can do this. So we're going to first find our slope for the 2 points that are given here. So for our slope, we want to go, well, what's the change in y over the change in x? So our change in y looks like it's going down by 1, and our change in x looks like it's going down by 2. So our slope looks like is going to be 1/2. So that is our step 1. Next, we're going to solve for our y-intercept. So I'm going to take the formula y equals mx plus b, and I'm going to plug in my 1/2 here for m, and then I'm going to pick one of the points here to plug in for x and y. It doesn't really matter which point you choose. I'm going to just use the first point here. So I'm going to take -2 and plug it in for y, and I'm going to take 3 and plug it in for x. And now we have an equation where we can solve to get b by itself. So we're going to multiply those and then subtract 1.5 from -2. So since we're subtracting, that will end up giving us -3.5. So we're just moving that over. That is now our b. So then our third step, we can write our equation. So our equation, our new equation, will be using this slope, y equals 1/2 x, and our new b, so minus